All right, so welcome back to the next lesson. Um, as we move towards learning more about the unit circle. So today we're using one trig value to find others. So today I'll be able to find exact values of all 6 trig functions. So before we get into this lesson, I wanted you to recall sine of theta equaling to r or y over r. And this r right here that we see, that r actually, I made this side note right here. Remember that r came from this formula right here, where r is equal to the square root of x squared plus y squared. So that's what I wanted you to recall, these equations and this formula, because you will need to use that again today. So with that being said, really quick as well, let me remind you that the sine of theta is equal to y over r, and its reciprocal function is cosecant theta. And so if you could see that the solution has been flipped from this one, or they're just reciprocals of one another. Let's just jump right in. So the goal is to find exact values of the 5 remaining trig functions. So as you can see here, there is a total of 6. They give us 1 here, so we need to find the other 5. So step 1, find coordinates of a point on the terminal side of theta. AKA, I need to figure out what quadrant this lands in. This example lands in. So this theta here, 5 over 12. If I were to have graphed this angle, where does it actually quote unquote land? Well, all right, so I need to bring this back up from last time. Basically this says if if your graph lands in the first quadrant here and it was a sine function, then it's positive and so forth. So we are a tangent theta. So I know for sure I'm only looking at my tangents so far. But look at what the information that the example gives us. It says tangent of theta equals 5 over 12, where sine of theta is less than 0. So that means it has to be positive or a negative number. If it's less than 0, then it's negative. So first of all, my solution is positive here, correct? So I need to only look in the quadrants where tangent is positive, and that's here or here. But the second condition is that sine of theta, we said, has to be negative, less than 0. So is sine of theta negative here? No. So it's not in this first quadrant. But is sine of theta negative here? Yes. So we know that our graph here, if I were to graph this, my angle measurement, 5 over 12, lands in this quadrant. Okay, so I rewrote my original equation. Now, we agree here that this would, if I graph this here, it lands in this quadrant here, right? And this is an x and y axis. This is x. Oh, yeah, and this is y. We know that numbers that exist here, here are positive. Numbers that exist here are positive. Numbers that exist maybe here and here, these are negative. So even though these two numbers were positive, let's think about this. Well, remember that they said up there that tangent of theta is equal to y over x. So technically, my coordinate points are 12 and 5. But is that possible since it lands and lives here in negative numbers? There's no way that these are actually both positive. This means that both of these numbers are negative. But the reason why my solution is positive is because if we were to have written it and kept it like this, that is not a simplified version. this ends up being a negative divided by a negative, which ends up being your positive number here. All right, so step 2, find the other trig values. That is the rest of these here. We already have tangent, but I need to know all of these. Okay, now one thing that you'll know is, okay, I already have my x, I already have my y. I could fill this in and substitute wherever there's an x, wherever there's a y. But what about the r? So that's where this comes in. So step 2.5, or a little bit of pre-work before getting into step 2 is actually solving for r. So r again is equal to x squared plus y squared. Oh, it's equal to the square root of that. Sorry about that. X squared plus y squared. Okay. Now let me substitute, remind myself that my x is negative 12, my y is negative 5. Negative 12. Why do I keep writing parentheses and forgetting about the square root? Square root of negative 12 squared plus negative 5 squared. And you can put those in parentheses if you'd like. That's 144 plus 25. And it does become positive because a negative times a negative is positive. All right. So that is the square root of 169. That's 13. Now, I have the whole gang here now. I know my x is equal to negative 12, y is equal to negative 5, and r is equal to 13. Now I'm able to fill in the rest of these. What are the solutions to all of this? Now, for sure, the one I'm going to start with is tangent. Since tangent, we already know that's the one we're solving for, is 5 over 12. What's the reciprocal of that? 12 over 5. Then you fill in the rest using this guide up here. Oh, and go ahead and pause this video if you wanted to check your answers for the problem of the first example. These are the answers. So go ahead and pause and check yours, see if you did it right. But moving on. All right, so first steps first. Before we actually do the first step, I want to remind you that don't be scared of this because, oops, I meant to highlight. Don't be scared because it's secant of theta and not the more common trig functions that we've been using, but just remind you that secant is the reciprocal of cosine. Okay, so secant of theta is related to cosine of theta. Just keep that in your mind. Now, the first step we had said up here was to figure out which quadrant that this would land in had it been graphed. So our answer, our solution here is positive. Okay. And because it's related to cosine and your secant or your cosecant or your cotangent don't live in this graph here, then what you want to look for is its reciprocal. So the reciprocal is cosine. So here it says that cosine of theta is positive, and here there's two conditions always. It might be more sometimes, but you need to consider both. That tangent of theta is less than 0, so something that's less than 0 is negative. So let's find what quadrant that happens in. So go ahead and pause and figure that out. I figured out that that actually lives here in the fourth quadrant. As you can see here, again, my cosine is positive. My tangent is negative. All right. So now let's move on. Let's see. So secant theta is equal to, let's go up here. Secant of theta is equal to r over x. I always want to make sure I know. That way I know what's my solution. Like, what do I have? Because I need what you need always in order for you to be successful with these problems is you need your x, you need your y, and you need not a z. You need an r. So you need an r. So because we know that secant of theta is equal to r over x, that means that our secant of theta is, well, they gave us that answer up here, square root 3. It doesn't have a denominator, but what could that denominator actually be if there's nothing there? A 1. So we already know that r is equal to square root 3 and x is equal to 1. Now I need to solve for y before I can actually move on to the second step, which that second step would be to do this process here. So how can I figure out what y is? Well, I know what r is. R is, again, the square root of x squared plus y squared. This is going to be my foundation to solve for y because I know r. R is the square root of 3. And I know what x is. X is the square, is 1, sorry, but 1 squared. I don't know what y is, so I'm just going to leave it like that. But I have enough information here to actually solve for y. So I have square root 3 is equal to, and I'm actually going to work this piece out. 1 squared is just 1 plus y squared. Now, how can I get y by itself? Well, it's kind of trapped in here in this square root. How do you get rid of square root? Square it. Whatever you do to one side, you do to the other. It kind of works out nicely here because there's a square root on this side, and that's going to cancel out as well. So that's going to be 3. This is going to look like 1 plus y squared because it cancels out that square root. Now, again, I'm solving for y here. So let me move this out of the way. That cancels. 3 minus 1 is 2. This is equal to y squared. How do I get y by itself? Square root it. So now we're bringing back that square root, and that cancels out, and square root 2 is equal to y. If I went too fast there, pause me and rewind me. So now the gang's all here. I have x is equal to, we said 1. Y is equal to, well, we just solved for that, square root 2. And r is equal to square root 3. Now I'm ready to do my step 2. This is kind of like side work. And I could now substitute in all of my solutions here. All right, let me wrap this up, but I just realized something. These solutions here, these are all not simplified, and the reason being is because you're actually not allowed to have a square root in the denominator. So let's take this first example, and then you'll do the rest on your own. But you need to cancel out the square root here in the denominator, cannot be there. So the best way to get rid of a square root is to multiply, to square it, right? And to square something is to multiply it by itself. So what I'm going to do here is multiply it by itself. But if you do something to the bottom of a fraction, the denominator, you have to do it to the top. So then what happens here is, because these two things are not the same, you just multiply the two numbers inside. So 2 times 3 is 6, and you keep the square root. But down here, because they are the same, the denominator ends up just being 3 because these square roots cancel out. So then your final solution would actually be square root 6 over 3. So all the ones that I highlighted here, make sure you simplify by doing this step. Now here are your practice problems. Go ahead and pause the video if you need to and take a picture of it, write it down. But just a few tips that I was thinking about is that maybe I wasn't so clear. This here is going to tell you whether or not, sine or cosine is positive or negative when you are checking your table here to decide which quadrant it lands in. And so this tells you, so now if it's saying cotangent of theta is greater than 0, any numbers greater than 0 are positive. But if it's saying less than 0, remember that's a negative number. Another thing is just be very careful here. As you can see, this problem and this one have two different, what is the word that I am looking for? I'm so sorry. Conditions that were sine of theta, cosine of theta, sine of theta, and cosine of theta. depending. These two have to be greater than 0. This one is one's greater than 0. The other is less than. So just be careful of that when you're trying to figure out, are my solutions positive, negative, and so forth.